Hey guys, it's Steven with myplctraining.com, and today I'm going to do a quick video on how to set up and use comparison instructions in Studio 5000 Logix Designer. So if you're wanting to start creating better PLC programs that handle analog inputs, or you just want to be able to understand and troubleshoot existing PLC programs better, then this video will help you get there. And if you're looking for more free PLC training, I want to let you know about a free cheat sheet I have where I'll show you the 3 things you need to know to understand any PLC system. These are 3 very simple things, but it's at the heart of every single PLC system. So if you're interested in that, be sure to click the link below so I can send you the cheat sheet and help you become a confident PLC programmer. Okay, let's talk about comparison instructions. So we're going to just jump right into this PLC program that I have open in Studio 5000 Logix Designer, and we'll take a look. So here we have one very simple rung, and this is as simple as it gets. We have one XIC, and it's being driven by a discrete input, which is from our slot 1 input module, which is an IB16, and it's input 0 of that input module. And that single XIC is driving a single OTE, and that is one of our discrete outputs on our slot 2 output module, and it's output 0 of that output module. So this is a yellow light for a tank, and this is a float switch for that tank that tells us when the tank is 80% full. And when it's full, this logic is pretty simple. We'll just force this to show it. So we force that, go to enable all IO forces, and you can see it turns on the yellow light, which is supposed to indicate that the tank is almost full. Okay, so really simple logic. And we also have an analog input that's coming in through this 1756 IF8 analog input module, and it tells us the exact level of the tank. So let's say it's a chemical solution tank, and this float sensor is going to tell us whether that solution is at 50% or 80% of the tank capacity, etc. So we could actually change this logic and have it do the same thing but use an analog input instead. So this comes on when the tank reaches 80%, so if it's 80% or more basically. So we could use a greater than or equal instruction under the comparison section here. Greater than or equal, and then I'm going to use the tag for the tank level percentage, and we're going to say greater than or equal to 80. And so now we have the same functionality as this, except we're doing it with the analog input instead of a discrete input. So when the tank level percentage reaches 80%, we'll turn on the yellow light, and as long as it's 80% or higher, it will stay on. Okay, so we can just execute that change, and then I'll just manually manipulate this tank level percentage. At 70, it's still off. 78, 79, still off, and then we go to 80, and it turns on. And it will stay on as long as we are above 80. So that's how we can use an analog input to do similar functionality as a discrete input, as long as the discrete input is monitoring the same system. So this logic now says if the analog input for the tank level is greater or equal to 80, we turn on the yellow light to say the tank is almost full. Now we could also add a rung of logic to turn on a green light. That says the tank is less than 50% full. So I've created a tag here, tank green light. And the analog input is going to be, we're going to put it in a comparison instruction here. So if it's less than 50%, we're going to turn on the tank green light and say, everything's cool, definitely ready to be filled up. So that's how that will work. So if I just send that setting, and then as I change this value to 50, this yellow light now comes off, but we're still not on here because this needs to be less than 50. So if we go to 49, that turns on the tank green light. So if we were going to do this with discrete inputs, we'd need a whole nother separate discrete input that was set up for turning off above or at 50% basically. And so we'd need two discrete inputs to do this logic, whereas we can use one analog input to do both these rungs. So analog inputs are nice that way because you can do logic based on a bunch of different data points rather than just one set point. Okay, so let's create another rung here. And what we're going to do is, let's say that this tank is supposed to stay between 20% and 85% full all the time. So if it ever gets outside of that range, we need to sound an alarm. So we could use a combination of comparison instructions like greater than or equal and less than. But I'm going to use a limit instruction which kind of combines them itself. So we can say the tank level percentage needs to be between 85 and, what did we say, 20% full. And we'll create a tag called tank within level limits. And then if we hit Control W, that will bring up a new tag editor here. So tank within level limits, we'll make it a Boolean, and we'll make it a controller scope tag, so it'll be there. Click create. And now we have this rung, which doesn't quite finish off what we need to do, but it does tell us whether the tank is within the correct level limits. So it's between 20 and 85, so everything's good. If we go to 21, it's still on. If we go to 84, it's still on. And if we go to 85, it's still on. So if we go above 85, that's when it turns off. Or if we go below 20, it turns off as well. So the logic we wanted, though, was to sound an alarm if it goes outside of this range. So let's add another rung, and we'll get an XIO, and tank within level limits. We'll say that when that bit is off, we're going to sound the alarm. So I'm going to create this new tag, tank outside limit alarm. And we're going to make this an alias to one of our discrete inputs, outputs. So local :0 : what did I do here? Local :2 : O dot data, and then we'll say it's output 2. Tank, and then, whoops. In our description, we can say exactly what will turn this alarm on. And so tank level is less than 20% or greater than 85%. And I think it's actually that less than or equal to 20%. Okay. There we go. And so then everything's happy. The alarm is not on. As long as the tank level percentage is there, we change it to 60. Whoops. 60, everything's fine. 76, everything's fine. Go down to 30. No problems. Go down to 20. And 19. And now we're outside of the level limits. And actually, let's change this to less than 20%. Outside the level limit, this bit turns off, which then allows this XIO to close, so it's like a normally closed contact that is closed when de-energized. So that closes and turns on our tank outside limit alarm. And likewise, if we go above 85, that's going to sound that alarm or turn on that alarm light as well. Now the last thing I want to show you is the same things, but we're going to use a generic compare instruction. So we're going to not change any of the logic except these compare instructions, and we're going to have it do the same thing. So we have, you can create logic with certain with the compare instruction and make it do whatever you want. So these are very specific, but if you want, you can use this and then write your own logic. So if we open this up and change this to a CMP, and then we say tank level percentage, use the less than symbol, equal 80. So now we just typed out our equation basically. So I'm going to copy that because we're going to use it again. And we'll make this a CMP as well, compare instruction. And before we were doing less than 50, actually this should be greater than or equal to 80, my bad. So this one's less than 50. This one is greater than or equal to 80. Okay, so we're going to change this limit into 2 comparison instructions. So we'll change this to a CMP, and we'll say tank level percentage. And if it's a correct tag, it will turn reddish. If it's not, it'll be underlined like this. So if there's a real tag called that, it will validate it that way. So we'll say tank level percentage needs to be greater than or equal to 20. And then I'll copy and paste this, and it needs to be greater than or equal to 20 and less than or equal to 85. Okay, so then we finalize those edits, and we can see this will function exactly the same. Now, one downside of these comparison instructions is you cannot see the value of the tag unless you hover over the tag, and then you can't edit it on the fly. So if we want to edit the value of that analog tag on the fly, I'm going to open up the watch window here. We see tank level percentage shown, and so if I change it to 20, we're now within tank level limits. The alarm goes off. If I go to 85, we're still within limits. If I go to 86, we're now we're outside the limits. So there you go. That's how you can use comparison instructions in ladder logic, and you can use these CMPs to do anything, or you can use the pre-built less than, equal, or greater than, or less than or equal, etc. limit instructions. Play with that, see if you can make sense of some programs that you create yourself, or hopefully this will help you even with your troubleshooting if you're already doing that. And if you like this video and you're interested in getting more free training from myplctraining.com, be sure to check out the link below to get your free cheat sheet on the 3 things you need to know to understand any PLC system. This cheat sheet is really quick. It can really help you if you're new to PLC, so definitely encourage you to check it out. Thanks for watching, and we will talk to you next time.